Welcome, math lovers, to another video of the series 100 Problems Around the World from the channel Solutions from the Book. And today we have decided to visit a Morocco Math Olympiad of 2011 problem from the final phase of their grade 11, which is for students up to 17 years old. The problem statement is as follows. The trapezoid ABCD has bases AB and CD. The diagonals intersect at point P. Prove that area of triangle PAB plus area of triangle PCD is greater than area of triangle PBC plus area of triangle PDA. As always, if you have any solution to this problem, please present it in the comments. If not, let's go through a solution together. So we have covered the solution in order to go step by step through it together, and we will have that. First of all, we rewrite the request of the problem. So we have the trapezoid ABCD with bases AB and CD, the diagonals who intersect in point P, and we are asked to prove that the area of this triangle plus this triangle is greater than the sum of areas of this triangle and this triangle. Now, first of all, let's make some definitions. We have that APB is equal to CPD. They are equal, let's say, to x, to the angle x. And also APB plus BPC is equal to 180 degrees. On the other side, we know that the sinus of an angle x is equal to the sinus of an angle 180 minus x, because they have the same sign and everything. So now we can express the areas of the triangles we want to compare in another way, and we will have that triangle PAB has an area of 1 divided by 2 of PA times PB times the sinus of angle x. Triangle PCD will be equal to 1 divided by 2 of PC times PD times the sinus of the angle x over here. And in the same way, we have that for triangle PBC, we'll have 1 divided by 2 of PB times PC times the sinus of angle 180 degrees minus x. And the same for triangle PDA, that it is equal to 1 divided by 2 of PA times PD times the sinus of angle 180 minus x. Now, we have that triangles PAB and PCD are similar to each other because all their three angles are equal to each other. So these two angles are equal to each other, these two angles are equal to each other, and also these two angles are equal to each other because AB is parallel to CD. Now, from this similarity of PAB and PCD, we have that PA divided by PC is equal to PB divided by PD, which let's say we denote as the number T, where of course T is a positive real number. Now, the given inequality, by substituting the values of the areas that we found over here, will be equal to, we simplify on both sides 1 divided by 2 and sinus x on both sides, and we will get that this inequality is equivalent to PA times PB plus PC times PD is greater than PB times PC plus PA times PD. Now, we just saw here that PB times PC is equal to PA times PD, so the right-hand side is actually equal to 2 times PA times PD. So we want to prove this inequality over here, which is equivalent to the inequality that we want to prove to the problem. So in other things, let's divide both sides by PA times PD, which are two positive numbers, so we can do this division, and we have that PA times PB plus PC times PD divided by PA times PD should be greater than 2. Or, by simplifying, we should prove that PB divided by PD plus PC divided by PA is greater than 2. Now, as we said over here, these ratios are equal to a real positive number T because we have the similarity of these triangles. So this inequality, if we put T with this value over here, will become T plus 1 divided by T should be greater than 2, the inequality we want to prove. But we know by AMGM, given that T is a positive real number, T plus 1 divided by T is greater or equal than 2. Now, what we want to prove is that we cannot reach equality in this case in order to prove our inequality. Equality for this simple inequality is only reached when t is equal to 1. But when t is equal to 1, we have that ABCD should be a parallelogram, and the diagonals intersect and half each other at intersection point, which is not our case because ABCD is a trapezoid and is not a parallelogram. So the equality cannot be reached. And we can say finally, in this case, that t plus 1 divided by t is always greater than 2, which proves this inequality, which is equivalent to the inequality that we wanted to prove. The claim that we made is proved, and so the problem is solved. Tell me what do you think about this solution, and please come forward with other possible solutions. Thank you for your time. hope to see you on our next videos. Up to then, goodbye.